In this section, we will learn about harmonic motion. Harmonic motion is the motion which we can relate with a sine or cosine function. Let's suppose that I pull this mass down and release it. Then this mass will go up and then down and up and down. That motion will continue forever as long as there is no other outside force like gravity, friction with air, or someone touches it. This is the simplest example of harmonic motion. What we want to do is we want to relate the time with the height of the mass and graph it. So in the graph, the x-axis will represent the time and y-axis will represent the height. This 0 in height is equilibrium position. Meaning that is the starting position. In this picture, this is the equilibrium position. I pull down the mass here, and then the motion will start from the lowest point, and then it'll pass the equilibrium point, and then it'll go up and start to go down and pass the equilibrium position and go to the lowest position and go up again. The motion will continue forever. As you can see, the motion resembles the flipped cosine function. So this is a graph of cosine function. Different from the cosine function, the input in this case is time, not an angle. Let me state more formally about simple harmonic motion. Simple harmonic motion is the equation of the displacement y of an object at time t. So the equation will look like y equals a times sine of omega t, or y equals a times cosine of omega t when omega is positive. Here, conventional notation is omega t. This is omega, not w. When we look at the simple harmonic motions equation, those are just a sine or cosine function, even though the meaning of this part is time instead of angle. So we can calculate the amplitude and period as we did. amplitude is apparently absolute value of A, but this is about physics. So the interpretation of absolute value of A is the maximum displacement of the object. The period is 2 pi divided by omega. We don't put absolute value because we already assumed that that is the positive number. This time, the period is time required to complete one cycle. After that, the same motion will continue forever. What's important to remember and what is absent in sine or cosine function was frequency. Frequency is the reciprocal of period, so we can formulate it as omega over 2 pi. This time, the meaning of frequency becomes number of cycles per unit of time. So how many times it oscillates in the unit period of time is the frequency. All you have to remember here is the frequency, the relationship between frequency and period is reciprocal. The next problem is the displacement of a mass suspended by a spring is modeled by y equals 10 sine 4 pi t, where y is measured in inches and t in seconds. Y equals 10 sine 4 pi t is the equation we have to work on. The first question is find the amplitude, period, and frequency of the motion of the mass. We are talking about the physical equation. However, that doesn't change the mathematical notion of amplitude period. So amplitude is the number in front of sine. This time that is positive, so that is just a 10. Period by its formula is 2 pi over 4 pi. 4 pi came from here. So that is 1 over 2. Frequency is 1 over period. We already calculated the period and we have to flip it, then that is 2. So in this problem, t was measured in seconds and the frequency is how many times it oscillates in the unit period of time. So we have the meaning of frequency is cycles per second. In other words, that is denoted as Hz, which is hertz. The meaning of hertz is cycles per second. In the second problem, we want to sketch the graph of displacement of the mass. When we graph sine and cosine function, we considered amplitude and period, and we needed key points. Let's clarify the key points. The period is 1 over 2. Key points divide that interval into 4 equal intervals. So 1 over 4 times 1 over 2 is the first benchmark. That is 1 over 8. On the other hand, I said each interval length will be exactly the same. So if first number is 1/8, then the second one is 2/8, the third one is 3/8, but 2/8 can be reduced to 1/4. Let's go with that. Here is t, and the amplitude was 10. So maximum point will be 10 and minimum point will be -10. So the first one is 1/8, the next one is 1/4, then 3/8, 4/8 is 1/2, and then 5 over 8. The function is 10 times sine 4 pi t, so there is no vertical shift. It passes the origin and there is no reflection, so it'll follow the typical pattern of the sine function. We don't extend the graph to the left because we start from the time 0. Next example, the displacement of a mass suspended by a spring is modeled by y equals 7 cosine of 1/4 t, where y is measured in inches and t in seconds. The first question is find the amplitude period and frequency of the motion of the mass. This time we work with the cosine function. Amplitude is the number in front of the cosine function, that is 7. Period is 2 pi divided by the number in front of the variable, which is 1/4. This is the numerator, this is the denominator, so we can re-express that as numerator times the reciprocal of the denominator, which is 4/1, which is 4. So when we multiply that, that is 8 pi. So we got period, frequency can be obtained by reciprocal of period. Reciprocal of period is 1/8 pi. In this question, they're not asking you to round up to a certain extent. So they're just asking you about finding the exact value. So we don't use calculator. This is the final answer. That is cycle per second, hertz. The next question is sketching a graph of the displacement of the mass. We already got amplitude and period. All we have to think about is key points before we actually graph it. The period is 8 pi. We subdivide into 4 equal intervals. So I don't have to write down the formula because 1/4 of 8 is apparently 2, then 4, and 6 pi. the x-axis is time and y-axis is the displacement. The maximum was 7 because the amplitude was 7 and minimum is -7. So every 2 pi there are important turning points, benchmarks. This time we are talking about this cosine. What we have to observe is there is no vertical or horizontal reflection because there is no minus sign. So it'll follow the typical graph of cosine. It'll start at the maximum and then go down and up. The kind of examples we worked on requires us to find the amplitude, period, and frequency, and then graph the function. This time, we will work on the problem whose logic is a kind of backward. Find a function that models the simple motion, harmonic motion, whose amplitude is 100 feet and period is 0.5 minute. Assume that the displacement is at its maximum at time t equals 0. This time, what is given in the problem is the amplitude. Amplitude is 100 feet and the period is 0.5 minute and it starts at the maximum, so we can relate that with the cosine function. Without any reflection. If we graph it, then based on the amplitude, the maximum becomes 100. The minimum becomes -100, and it starts at the maximum and then oscillated. The one period is here, so that is 0.5. This is time. Let's figure out the equation. Let's put y equals a times cosine of omega t. Then amplitude is given as 100, so we can easily say that a is 100 and period is 0.5 that came from 2 pi divided by omega. So we multiply by omega on both sides, then that becomes 0.5 omega equals 2 pi. And a 0.5 is 1/2, so 1/2 omega equals 2 pi. So we multiply by 2 on both sides, then omega equals 4 pi. Once we figured out omega, we can conclude the problem by combining with A. So the final answer for this question is y equals 100 cosine of 4 pi t. The model of this harmonic motion was related to cosine. The next problem, it'll be related to sine. Find a function that models the simple harmonic motion whose amplitude is 1.7 meter and frequency is 0.5 hertz. Assume that the displacement is 0. At time t equals 0. The condition which is given here is amplitude 1.7 meter. This time, instead of giving us period, they are giving us frequency. What we have to keep in mind is frequency is the reciprocal of period. And the other important clue is at the time 0, the displacement is 0. So that implies that is related to the sine function. So harmonic motion's mathematical model will be y equals a times sine of omega t. Amplitude is related to a, that equals 1.7, which is given here. As I said, frequency is 1 over period. That is given as 0.5, which we can convert that into 1 over 2. That equals omega over 2 pi. Or you can, yeah, so that is frequency. So instead of 2 pi over omega, you will just write the reciprocal of that, omega over 2 pi. So we will use this part to solve for omega. Omega over 2 pi equals 1 over 2. So we multiply by 2 pi on both sides. Then these two will cancel each other. And these two will cancel each other. So omega equals pi. So the final answer is y equals 1.7 sine of omega, which is pi times t. Here the period was 2 pi over omega, and then we flipped it for reciprocal. If I add some more explanation, that's it for harmonic motion.